Boys and girls, ladies and gentlemen, today I'm going to show you how to build your first ever trading algorithm backtester with Python. And we're going to probably do this in just under 10 minutes. The strategy we're going to implement today is a simple moving average, where we have a fast moving average and a slow moving average, and it is plotted on the same plot as the closing prices of a stock. Essentially, if the fast moving average moves above the slow moving average, it will give us an indication that we're going to start a reversal or an uptrend. So we're going to buy. We then wait for this fast moving average to then go below the slow moving average, and that is our indicator to sell the stock. If you don't know how moving averages work at all, it's pretty simple. Essentially, you have a window size. So it could be 20 days, it could be 50 days. In stock prices is usually the amount of prices. So if we're doing it amongst closing prices, we add up all of the 20 prices in that window together and then divide it by 20. Hence the moving average, because then we move 20 ahead, add those prices together and divide by 20 again. For instance, we can show the fast moving average with a 20-day, and then we can show the slow moving average with a 50-day. We take the window size, whether it's 20 or 50, and divide it by the total amount of prices in that window. This makes the fast moving average fit more to all the edges, peaks, and valleys within the market, and then the slow moving average moves less but shows a bigger trend over a longer period of time. Now let's code up this junkie. I split this code into multiple files so then you can keep track of what's going on in what file. First, we have the main.py. Main.py is in charge of calling all the other functions amongst all the files, and I made this program acceptable with command line arguments. This way we could check how good my boy Nvidia with his super sexy GPUs are doing and compare it to the gamers at Microsoft and see how they compare to one another. We can also adjust how big the window size for the fast and slow moving average is and see how the different numbers compare to one another with the different stocks. I also added in this file a comparison as if you were to buy from day one of the period and then sell it at the end, because why would you use the bot if you could just buy it on day one and sell it and not have to worry about this whole bot thing in the first place? That is essentially our baseline, is the buy and hold strategy, which basically just you're buying it and selling it on the last day. Data.py is essentially in charge of grabbing the data from some other source. I used yfinance. I thought it was a super easy platform. I've never used yfinance before, but I looked into it and it was a very easy library to import and use with Python. So data.py has the historical data function and the add SMA, or simple moving average, function. Historical data uses yfinance to grab data from online of the stock prices, so that way we can import it into our trading bot. Add SMA uses the pandas pre-built-in function .rolling and .mean, so that way we don't have to manually code the moving average like I said before. This thing already automatically does it. Strategy.py focuses on, you guessed it, our strategy. When are we buying and selling in these markets? We need a bull value to tell us if we're currently in a trade or not, or basically tell the bot, are we in a trade or not? We need to record the price when we buy and the total profit over the period. And then we have a first buy price for the first purchase we make in order to later on calculate our percent return. We then need to keep track of our fast and slow moving averages for the previous or yesterday's fast and slow moving averages and today's fast and slow moving averages. And then obviously the close price is the price that it's currently at, or the price that the stock is currently at, or what we would be buying the price at. And we only need to keep track of that row, not the entire column. Boys, I messed this up because I'm trash. Honestly, you just have to add the .ilock. I completely missed that I needed to add that in there. We then start the logic for when to buy. And essentially we just look if yesterday the fast moving average was under the slow moving average, and then today the fast moving average is above the slow moving average, we need to execute our buy, making our in position now true, and our buy price is now equal to the current closing price of whatever the stock is at. We then also record our signal column as a 1, and I will tell you later why we do this. For our sell indicator, it is the same exact thing, but almost reversed. We then look, yesterday was the fast moving average above the slow moving average, and today is the fast moving average below the slow moving average. Let's sell, take our profit, calculate the profit, and add it to our total profit, add a signal of -1, and indicate to the bot that we're out of position now. Finally, we calculate our percent return, so then we can compare this to our buy and hold value to see if this was actually worth doing. To finish off the code, we then have a plot my stock function, which essentially takes all of what we just did and puts it onto a plot so that you can see it visually. I started off by just plotting the closing prices of the stock and then also the slow and fast moving average of your selection over the period that you select. And then I added, obviously on top of that, with plt.scatter, we can add on based off of that signal column we added. If it's 1, we basically add a green arrow indicated that we bought at that position. Then finally, we can run our script. That's fire. Fire. You want Apple? Boom. You want Nvidia? Boom. You want Microsoft? Boom. I did some testing on my own, and we can actually see Nvidia outperforms buy and hold by a good percentage amount when we do a fast moving average of 20 and a slow moving average of 35. We can then see that this gets reversed when we bump up the slow moving average to 50. We can then see the difference that when we move our slow moving average to 50, it seems like you should just buy and hold, my guy. Sadly, it is not the best backtesting algorithm. Because we have to check the previous day and the current day, there's basically a lag in when we actually buy or purchase in this market. So the bot reacts after the price movement actually happens, which is obviously bad if we're trading on a live account. We also didn't talk about the instances where if markets aren't moving up or down, but rather just sideways, it can cause buy errors and sell errors, and also just sometimes not even trade or execute at all. Also, you have to take into consideration, if we were doing this on a live account, we are not indicating any stop losses or take profits, and this uses 100% of your account every single time you trade. So if the fast moving average actually never crosses the slow moving average and you're stuck in a downtrend somehow, I don't know how, you lose everything. So there's no risk management in this algorithm. But on the very positive side, this is a great baseline bot to get you guys to learn and design basic logic for time series data. If we wanted to make a live bot, we would have to implement some things like risk management strategies and some more sophisticated statistics like standard deviations and Bollinger Bands. Thank you guys so much for watching though. I will post the code to GitHub for everybody to take a look at, but I challenge you guys to do this on your own, because that's the best way to learn, is to just do this stuff on your own and think about the way that this algorithm actually works from scratch. Drop a comment if you guys want to see something in the future, and obviously leave a like if you feel so inclined. But I hope you guys enjoyed. You stay to the end, you're a stud. Peace. I've had a little bit too much. All of the people stop. We out here right now. What they doing over there? They gonna jump. They done with